Alright, so for number 3, I have already gone through and written all the p factors and all the q factors. So the factors for 6 are 1, 2, 3, and 6, of course, plus or minus. The factors for 2, the leading coefficient are 1 and 2. So now I'm going to go through and do p over q. So you take all the values, all the numbers in p, and put them over the numbers in q. So 1 over 1, and again I'm getting this one right here over this one right here. So that's going to give you 1. And then 1 over 2, and that's going to give you plus or minus 1/2. And then you go to the next number, 2 over 1. So that's going to give you plus or minus 2. And then 2 over 2 is 1, but you already have a 1 right here, so you don't have to write it again. So now you move on to the 3. So 3 over 1, that's 3. And then 3 over 2, that's 3/2. And then 6. 6 over 1 is 6, and 6 over 2 is 3, but you already have a 3 right here. So you don't actually need another comma because that's the end. So this is the list. If this polynomial has a rational 0, that rational 0 is going to come out of this list. So the next thing we do is synthetic division to find the 0. I'll start with 1. And so it's 2, negative 1, negative 13, negative 6. Bring down the 2, 1, negative 13, and I get negative 19. Okay, so that one didn't work. Then I move on to 2. I could do the 1/2, I guess, but usually I do the whole numbers first, the positive ones, and then if those don't work, then I'll go to the fractions. So bring down the 2, 4, 1, 2, negative 11, negative 22, so that gives me negative 28. Okay, then I'll try 3. 2, negative 1, negative 13, negative 6. That gives you, bring down the 2, 6. And then 5, 15, then 2 and 6, and this one worked. Okay, so this one works. Okay, and so now, what does that mean? I've got the remainder 0, and I've got 252, which represents 2x squared plus 5x plus 2. And so I've got to factor that polynomial further. Okay, so I'm going to do the 2 times 2, that's 4x squared. And factors of 4 that add up to 5 are 4x and 1x. And then you could factor whichever method you prefer. I'm going to just use the box method. So 2x squared, 4x, x, and 2. Factor out a 2x. Then 2x times x gives you 2x squared. 2x times 2 give you 4x. And x times 1 gives you x. And 1 times 2 equals 2. So this is the other pair of factors for 2x squared plus 5x plus 2. So now f of x equals, from this 0 right here, I get x minus 3. And then from the factored form of the quadratic, I have x plus 2 and 2x plus 1. So this is the factored form of the polynomial. Okay, from the factored form, I could find the zeros, which are 3, which of course I already knew right here that it was 3, right? And then negative 2 and negative 1/2. Now for those of you who have trouble making a connection from 2x plus 1 to negative 1/2, all you have to do is set this equal to 0 and solve for x. So subtract the 1, divide by 2, and that gives you the negative 1/2. So here is the set of zeros, and that's it. Alright, so for number 4, we have the p factors, or the p numbers, are factors of 15. So you see right here, 1, 3, 5, and 15 are all factors of 15. For the leading coefficient, I have a 1, so the q factors are just plus or minus 1. So now when you do p over q, because q is plus or minus 1, then basically it's this list right here. Okay, because they're all going to go over 1, which will mean that it's just the same numbers. So let me start with 1. And we get 1 minus 9, 23, negative 15. Bring down the 1, negative 8, 15, 15, and 0. And it worked. First one worked. Cool. Okay, so what does that mean now? That these three numbers represent x squared minus 8x plus 15. Well, factors of 15 that add up to 8 are 3 and 5, well, negative 3 and negative 5. And because this is a 1 leading coefficient, we don't have to do the box or the x factor. You can just break it up into x minus 3 times x minus 5. So this one's going to be f of x equals x minus 1, and that x minus 1 comes from here, and then x minus 3 times x minus 5. And this comes from x squared minus 8x plus 15. So the zeros are 1, 3, and 5. And that's what you have to write as an answer. Alright, so number 5, you have h of x equals x cubed, and so forth and so on. I already wrote the factors of 8 right here, 1, 2, 4, and 8, the factors of 1, plus or minus 1. And again, when q is just plus or minus 1, the ratio p over q is simply the values of p, because we're going to put all these numbers over 1, which means they stay the same, right? They don't change. A number over 1 is the number itself. So the p over q list is the same list as the p list. So now we're going to start synthetic division, starting with 1, and then negative 5, 2, and 8. Bring down the 1, negative 4, negative 2, negative 2, and 6. So this one did not work. We move on to the next number, 2. 1, negative 5, 2, and 8. Bring down the 1, 2, negative 3, negative 6, negative 4, and then negative 8. So this one works. Okay, so this means that x minus 2 is a factor. Okay, and these three numbers represent the quadratic. So quadratic is x squared minus 3x minus 4. So factors of negative 4 that add up to negative 3 are negative 4 times 1. Okay, again, because the leading coefficient is 1, you don't have to do box method or x factor. You could go straight to just the factor x minus 4, x plus 1. So f of x equals x minus 2, and again, that comes from here, and then x minus 4 times x plus 1, and these two factors come from here. Okay, so the zeros are 2, 4, and negative 1, and that would be the final answer. Alright, so for number 6, I've listed the p factors and the q factors. So for p, it's only plus or minus 1, plus or minus 2, because the constant is 2. For the q factors, it's 1, 2, 3, and 6, because the leading coefficient is 6. So now I'm going to take p over q. So remember, we take this number over this number, and this number over that same number. Okay, or actually we can do the 1 first over each one, and then the 2 over each one. So 1 over 1, is plus or minus 1. 1 over 2, and again I'm talking about this 1 over this 2, okay, is plus or minus 1/2. 1 over 3 is 1/3. And 1 over 6 is 1/6. Okay? So now we're going to do the 2's. 2 over 1 is 2. Andrew. 2 over 2 is 1, but we already have a 1 right here, so we're not going to write it again. 2 over 3, oops, is 2/3. And 2 over 6 is 1/3, but we already have it right here. We already have it right here, so we're not going to write it again, so we don't really need that comma, because that's the last number. So then this is the list of possible rational zeros that would work for this polynomial. Okay, so using this list right here, I'll start with, let's see, I'll start with the whole number, so I'll start with 1. So 6, negative 7, negative 9, negative 2. Bring down the 6. 6 times 1 is 6. Combine, you get negative 1. Negative 1 times 1 is negative 1. Negative 10, negative, so this is not going to work, right? Negative 12. So I'll skip over and go over to 2. 6, negative 7, negative 9, negative 2. Bring down the 6. 6 times 2 is 12. This gives you 5. Then this gives you 10. 1, 2, and it worked. Okay, so what does that mean? That this is a quadratic. 6x squared plus 5x plus 1. We're going to factor it into 6x squared. And, well, you multiply it first, right? And then you're looking for factors of 6 that add up to 5. So that would be 3x times 2x. So I'm going to use a little box. 6x squared, 3x, 2x, and 1. Greatest common factor in the first row is 3x. Then 2x times 3x is 6x squared. 1 times 3x is 3x. 2x times 1 is 2x, and 1 times 1 is 1, so that works. So my factored form, I'm first going to take the first factor from here, so that's going to give me x minus 2. And then from the quadratic, I'm going to take 2x plus 1 and 3x plus 1. So remember, this comes from 6x squared plus 5x plus 1. So the zeros are 2, negative 1/2, negative 1/3. And again, if you have trouble seeing the negative 1/2 and negative 1/3, don't worry. Just write out 2x plus 1 equals 0 and 3x plus 1 equals 0 and solve it. Solve each equation and you'll get your negative 1/2 and your negative 1/3. So this is the final answer, the factored form and the zeros. So number 7, I tried the box method, factor by grouping. And this one happens to work. If you factor out the greatest common factor on the top, you get x squared on the first row. And then x something times x squared gives you x cubed, that would be x. And then something times x squared gives you negative x squared, that's negative 1. And then x times negative 1 gives you negative x. And then you always check, is negative 1 times negative 1 equals to positive 1? The answer is yes. So the factored form of this polynomial is x minus 1 times x squared minus 1. Now this is difference of squares, so it factors more, right? So this would be x plus 1, x minus 1. That's your difference of squares right there. And so I notice how it has 2x minus 1, so I can just combine it as x minus 1 squared, and then x plus 1. And so that would be the factored form of the polynomial. The zeros are 1 and negative 1. Okay, if you were to graph this, 1 and negative 1, the multiplicity of positive 1 is even, so that means it would touch, and then it would cross negative 1, so it'd be down up, so it goes something like this. It would be tangent right there, and that would be the graph, with this being 1.